here we're told that a supermarket sells rolls of aluminum foil, plastic wrap, and wax paper. First thing we're going to do is describe a capacitor made from such materials. Here, you have free range to really make up anything you want. What I mean by that is, sure, we have conductor here, but we have two insulators. You could pick plastic wrap or you could pick wax paper, and then you can decide how big you want everything to be. So here, we're going to do 2 sheets of aluminum. And we're going to say, okay, well, 40 centimeters by 100 centimeters. It doesn't matter, pick whatever numbers you feel like. And then we're going to have 1 sheet of, let's say, plastic wrap. Same dimensions, so 40 centimeters by 100 centimeters. So this is A. Now B says, compute the order of magnitude estimates for its capacitance. So what is its capacitance? Well, we know that K is approximately equal to 3 and E max is about 10 to the 7 volts per meter, and thickness is about 2.54 times 10 to the negative 5 meters for plastic. So these are all things that you can look up. You can figure out, well, what is K for plastic? What is its E max before it turns into a conductor, essentially? Thickness, you can also look that up. You can kind of estimate a little bit. And then we know that C, capacitance, is K epsilon naught A divided by D. So here we're going to have 3 for K, and then epsilon naught is 8.85 times 10 to the negative 12 C squared divided by Newton meter squared. And then for A, the area, right, this is our area of our plastic, and it's 40 centimeters times 100 centimeters. So that's going to be 0.4 meters squared. And then we're going to divide all of this by the thickness of our capacitor system. And that is going to be 2.54 times 10 to the negative 5 meters. So all of these numbers, well, this one's not an estimate, but this one and this one, they're all kind of I don't know, either you make it up or you approximate something. It's really just to figure out how to put everything into this equation here. And that is going to be about 10 to the negative 6 farads. And this is what they're asking for, an order of magnitude. They don't care about the numbers that come before it. They really just want to know 10 to the power of what farads. So that's the capacitance of our little capacitor system. Now C says, what is the order of magnitude estimate for its breakdown voltage? So we know what E max is. This is the maximum electric field that we can have in between our capacitor plates. So it's a maximum E that we can have in between here before our capacitor breaks down. And by breakdown, it means it goes from being an insulator to acting like a conductor. And we know that delta V max is equal to E max times D for parallel plate capacitor. So then we just have to say, well, what is E max? It's approximately 10 to the 7 for plastic. So 10 to the 7, and the units are volts per meter. And then D, where we know what D is, it's going to be this thickness here. And that's about 2.54 times 10 to the negative 5 meters. And that's going to give us about 10 to the 2 volts. So if we send in about 10 to the 2 volts for a capacitor of this size here, we're gonna break it. And that is about it. But yeah, you can do this problem a million different ways, and it's really just figuring out how to use these equations here.